Hello everyone, welcome to AJ Programming Solutions. So in last video we have seen the features of the Java and how to write our first Java program. So in today's session we will see what is variable, how to create the variable and what are the rules we need to remember when we create the variable, and after that we will talk about the data types. Okay, now let's start with the variable. Let me just go to the IntelliJ. Okay, and here we will see what is the variable, right? So see, what is the variable? Variable means variable is actually a container which holds some value. For example, let's suppose I have a number 10, okay, and I want to store this number somewhere, right? So I will be using the variable name. Okay, so how I can write it? I can write int num is equal to 10. Okay, so now here this num is a variable name and this 10 is a value which we have assigned to the variable num. Okay, so variable is a container which holds some value, right? So here 10 is a value which is holding by this num variable, right? Now let's suppose if I want to store the name of the animal, let's suppose. Okay, so I can write here string name is equal to, and I can just write here cat, right? So this way you can assign the value to the variable. So here this is a variable name and this is a value and this is a type, which type of variable you are creating, right? So this is of type string, this is of type integer. So this way we can create the variables. Okay, now while creating the variables we need to remember some rules. Okay, so what are the rules we need to remember? Very first rule while creating the variable is that variable should not start with the number. Okay, should not start with the number. This is the rule we have. For example, if I try to write here int 2 num is equal to 20. See here, I am getting the compile time error because you have started the variable name with the number and this is not allowed in the Java. Okay, if I save this and execute the code, see what error you are getting. Okay, let's just execute the code. See here, not a statement. Okay, so meaning is that you can't start the variable name with the number. Okay, this is the first rule which you need to remember. But it's not like you can't use the number in a variable name. Okay, only thing is that you can't use first letter as a number in your variable name. But if you want to use it in any other place, let's suppose here you want to use num1, it's allowed. Okay, so you can use at last or maybe in between. If you want to use in between the digit, then also you can use it, but only thing is that the initial or the first letter should not be a number. You can use it in any other place. Okay, this is a first rule. Now the second rule is that in the variable name only allowed symbols are dollar and underscore. Okay, so we have different special symbols, right? For example, at the rate, then hash, then percentage, or maybe and percent, right? So we can't use this as a variable name, or you can't use these symbols in your variable name. Okay, so this is not allowed. Okay, for example, here if I try to write int name and here if I try to write at the rate, okay, and is equal to, I will just give xyz name. See here, whenever I try to use this at the rate symbol, I am getting the compile time error, right? Even if let's suppose I try to use the hash, then also I am getting the compile time error. If I save this and execute the code, see what error we will get. Okay, when we try to use these special symbols in our variable name. Okay, so see here, let's suppose if I go Okay, let me just execute it again. Okay, so see here what error we are getting, illegal character hash. So you can't use hash in your variable name. Okay, now only allowed symbols are dollar and underscore. So you can use here dollar. See, you are getting, okay, sorry, this is not of integer type, it should be a string. Okay, so now see here, if you try to use the dollar, it is not giving any issue, but instead of dollar, if you write hash, then it will give you the error. What is the error? Illegal character hash. So you can't use hash in your variable name. Okay, you can use dollar and you can use underscore. Only two symbols are allowed, which is dollar and underscore. All other symbols are not allowed in a variable name. This is a second rule which you need to remember. Okay, now the third rule is that we have some reserved keyword in the Java, right? So what are the reserved keyword we have? For example, we have if, then we have else, right? Or maybe switch. So these are some keywords we already have in the Java. So reserved keyword means these keywords are already known to the compiler, right? Because they are already created in a Java. This is not user defined keywords, right? So now you can't use these keywords as a variable name in a Java. For example, if you try to write here int if is equal to 2, then it's not allowed. See here, you are getting the error. Okay, this is a compile time error. It is saying that you can't use if as a variable name. Even you can't use else, switch, any reserved keyword, you can't use it as a variable name. Okay, so this is the third rule you need to remember. Okay, now let me just go to the slides. I have written all of this in the slide. See here, what are the rules for the variable name? Very first rule is that variable name should not begin with the number. Then only allowed symbols in your variable name are dollar and underscore. Third rule is that we can't use reserved words as an identifier or variable. For example, see here, if I try to use else is equal to 20, it will give you a compile time error because else is already reserved, right? Now the fourth rule is that all predefined Java class names and the interface names we can use as an identifier or the variable name, but it's not good programming practice. Meaning is that if I go to the IntelliJ, okay, and here let's suppose if I try to use the inbuilt class as a variable name, right? Inbuilt class means what? The class which is already present in the Java, the class which we have not created, that was already present in the Java. For example, this is string is a class which is created already in the Java, right? So this is inbuilt class. So we can use this inbuilt class name as a variable name, but it is not a good programming practice, right? For example, here if I try to use int string is equal to 30, it will not give you any compile time error because this is allowed in the Java, but this is not a good programming practice. Okay, this is the fourth rule we have when we create the variables. I hope this is clear to everyone. First thing is that what is variable? Variable is a container which holds some value. Then when we create the variable name should not begin with the number. Only allowed symbols are dollar and underscore. Then any reserved word we can't use as a variable name. Any predefined Java classes or the interface names we can use as an identifier, but it's not a good practice. Okay, so these are only rules you need to remember whenever you create the variables. Okay, so this is about the variables. I hope this is clear to everyone. Okay, now let's go to the next topic, which is data types. Okay, now what are the data types we have in the Java? We have primitive data types and non-primitive data types, right? In the primitive data types we have integer, float, short, byte. In the non-primitive data types we have class, string, array. Okay, so now in today's video we will talk about the primitive data types, and about this non-primitive data types we will talk in some other sessions. Okay, now see here, we have these many primitive data types: byte, short, int, long, float, double, character and boolean. Okay, now what you need to understand is that for the byte the size is 8 bits. Okay, and the range is -128 to 127. And what is the default value for the byte? The default value for the byte is 0. Okay, for the short the size is 16 bits and this is the range, and default value for short is also 0. For the integer it is 32 bits and the default value is 0. Okay, now for the long it is 64 bits and the default value is 0. Same way for the float, the default value is 0.0 but the size is 32 bits. For the double the size is 64 bits and the default value is 0.0, right? For the character it is 16 bits and the default value is /u0000. Okay, and for the boolean data type the size is 1 bit and the default value is false. Okay, now if we go to the IntelliJ, let me just go to the IntelliJ. Okay, and here we will see what are the data types we have, how we can create it, right? So see, in the primitive we have integer data type. Okay, we have long data type, then we have boolean, we have float, right, double, etc. Okay, now how we can create this? Okay, let's suppose, see, integer data type means what? It will hold the integer value. For example, here if I create int n is equal to 10. Okay, so n is the variable name and int is a data type for this variable. Okay, so in the integer you can assign the number values or the integer numerical values. Okay, now for the long also you can assign the numerical value. For example, here if you want long L is equal to 20. Okay, so whenever you create the long variable, that time you can use here L, small l or capital L. Okay, so whenever you are writing L after the value, then it denotes that this is of type long. Okay, now for the float, if you want to create the floating point values or the decimal values, if you want to store the decimal values, that time you will be using float or double. For example, here let's suppose I want to store the value 10.20. Okay, so to store the value 10.20 you can just use float data type. Float f is equal to 10.20, and here whenever you create the float variable, that time you should always write small f or capital F, so that it will donate this is of type float. And if you are not writing anything, it means by default it is of type double. Okay, for example, here double d is equal to 20.2, right? So for the double data type you can store or you can assign the floating values, I mean the decimal point values, but you don't need to write here anything. So by default if you have any decimal point values, it will be a double type. Okay, and if you want to make it as a float, you need to write it f here. Okay, so this is the what we can say, the difference you can consider in the float and double. Okay, so default it will be of double type. If you want to make it as a float, you can write here capital F or small f. Okay, now this is for the integer, this is for the long, this is float and double, right? Now for the boolean, you can write boolean and then b is equal to, here the allowed values are only two, one is true and another is false. Okay, so these are only allowed values we have in the boolean, and the default value for the boolean is a false. If you are not assigning anything, then the default value for that particular variable will be false. Okay, now the another thing which we have is a character, right? So if you have any single character, for example yes, then you can store it in the character variable, right? But you can't store multiple characters. See here, as soon as I add one more character, it is giving you compile time error, because in the character data type you can store only one character. Okay, now we have the byte. Okay, so in the byte you can write maybe b1 is equal to 20. Okay, byte, right? So in the byte you can assign the numerical values also. Okay, then what is remaining? We have int, long, float, double, boolean, character and byte. Okay, so these are the primitive data types we have. Now we will, whenever we will write some code, that time you will see that we will be using all of these data types frequently. Okay, so when we use this type of this data type, then you will get more understanding about each and every data type. Okay, but uh, at the high level, I think you should understood by now that integer and long, this will be storing the numerical values. Okay, then float and double will store the decimal point values, right? Boolean is whenever you want to store true and false value, or whenever you want to indicate that that variable will be having only two possibilities, which will be true and false, then you will assign that for the boolean data type, right? Whenever you want to store a single character, that time you can use a character as a data type. Okay, and byte also you can use if you have very short value. Okay, we have one more data type actually, the short, right? So in the short also you can use, like, let's suppose 10, right? So these are the data types we have in the Java. Okay, now like here we have actually, let's just move to the another topic, okay, which is related to the data types only, and that is a casting. Okay, casting. So what is the meaning of casting? Okay, see here, in the integer, in the, if I go to the slides, you have seen that this is the size we have for the data types, right? So byte will only allowed the 8 bits, right? Now short is allowing only 16 bits, integer is allowing only 32 bits, long 64 bits. Okay, so meaning is that in the integer you can store the value of size 32 bits. If you try to assign the value which is greater than this, then it is not possible to store it in the integer, right? So if you have something which is greater than 32 bits, then you can use a long as a data type, right? So according to this size and the range, you will able to assign the value, right? Let's suppose for the byte you only have -128 to 127, right? But if you try to allocate 128 to the byte variable, then it's not possible, right? It will give you the error. For example, if I go to the IntelliJ, okay, and here if I try to write maybe byte byte num, or maybe byte n1 is equal to 12. Okay, so it will not give you any error because 12 is in the range of the byte, right? But now let's suppose if you try to write here 129, see here what it is saying, if I just over, it is saying required type is byte and you have provided integer, right? So the byte range is from minus 128 to 127, right? But you have assigned the value something greater than 127, and that's the reason you are getting this error, because byte can't hold that much size, right? The size of the byte is still 127 and you are trying to allocate something more than 127. Okay, so you can't do that. Okay, now here let's suppose this 129, right? This is of the greater size, right? It should allow till 127. If you write 127, it will not give you any error, but if you are writing 128 or 129, anything after 127, it will give you the error. Okay, now if you want to store the value greater than 127, then you can make it as a integer. Okay, now see here, if I make the variable data type as an integer, I am not getting any error, because integer have a capability to store this value, because integer is storing how much? Integer store 32 bits, right? So if I try to assign the value 127, it's pretty much possible to store in the integer data type. Okay, now what is the meaning of casting? Okay, casting means that you are casting one data type to the another data type. For example, let's suppose, okay, I have here a number float num, or maybe float f1, okay, and I have the value 23.3f. This is my float value, which is 23.3f. Okay, now we have we want to understand what is the casting. Okay, very first thing is that the casting is having two types. Okay, first is that implicit casting, and another is that explicit casting. Okay, so what is meaning of implicit? Implicit means the automatically the casting will happen, you don't have to do it explicitly. Okay, explicit means you need to do the casting explicitly. Okay, now when the implicit casting will happen, if you are trying to assign the lower value to the bigger data type. Okay, for example, if I go to the slides, see here, we have the long size as a 64 bits, okay, and integer size as a 32 bits, right? So integer is having 32 bits and long is having 64 bits, right? So long can have the integer values, right? Because integer size is a 32 bits and it can be stored in the long. Meaning is that here if I try to use, let's suppose here I have a number integer number is equal to 20. Okay, so this is my integer number. Okay, now I will create long L is equal to, or maybe long L2 is equal to this number. Okay, what I am trying to do here, this integer number I am trying to assign to this long variable. Okay, and now if I print here the L2 value, okay, if I store and execute the code, it will just print this 20. Okay, we are not getting any issue here. Now what happened, let me just execute this program first. See here, we are getting the value 20 in the L2 variable. Okay, now see here, what happened, implicit casting happen. How? This number is of type integer, right? And we have assigned this integer number to the long. Okay, so now internally this integer is converted to the long. Okay, the capacity of long is 64 bits and capacity of the integer is 32 bits. So this 32 bits values can be stored in the long, right? And that's the reason explicitly we don't have to cast it. So implicitly it will get casted to the long if See here you need to understand. Okay, this long is what? Here whatever you have at this side, it is your destination. Okay, and this is the source, you can say, right? So whenever your source is less than the target or the destination, that time the implicit casting will happen automatically. Okay, but now here let's just take the another example. Okay, let's suppose for the float, right? So if you go to the slides, see here, for the float what is the size? 32 bits. And for the double what is the size? 64 bits, right? Now the float values can be stored in the double because double is having a larger size. Okay, so you can just store the float values in a double data type. But if you try to store the double data type value to the float, then it will not happen automatically. For example, if I go to the IntelliJ and here I have let's suppose one double value, double d1 is equal to 23.3. this is my double value. Okay, now I create the float f2 is equal to d1. What I am trying to do now, I am trying to assign this double value d1 to the float. Okay, and what it is giving me the error, the required type is float but you have provided the double. Okay, now here understand that for the double the size is 64 bits. Okay, and for the float the size is 32 bits, right? So now this 32 bits is lesser than 64 bits, right? So you can store this double values into the float, right? So implicit casting will not happen, and that's the reason here you need to do the explicit casting. Means you need to tell to the compiler that I want to convert this double value to the float. Okay, and whenever we do the explicit casting, that time some data will get losted. Why? Because float can only store 32 bits value, right? And double can have 64 bits values, right? So whenever you do the explicit casting, some data will get losted. Okay, so now how we can do the explicit casting? Here you need to mention that I want to convert this double to the float. So here you will be writing float. Okay, and whenever you do the explicit casting, it will not give you any error. Okay, one more example is that let's suppose we have the value integer, let's suppose num2, okay, is equal to 20. Or maybe what I can do, I can just create one variable float, f is equal to 23.5 f. This is my float value or float data type we have used for this variable ff, and value is 23.5. okay, now I create one more variable int num3, okay, and I try to assign this float value to the integer type. Okay, so I will be writing here ff. What I did here, I am trying to assign the float value to the integer data type. So it is giving me error because float can store the decimal points but integer can't store the decimal points, right? So now in this case we need to do the explicit casting. And how we can do the explicit casting? Here you just need to add in which data type you want to cast it, right? So I want to cast it to the integer, so I will be writing here integer. Okay, as soon as I write the integer, then the compile time error will be gone. Okay, but here what will happen, as integer can store only integral values, it can't hold the decimal points. So whatever is there as a decimal points, that will get losted. Okay, for example, here if I print num3, okay, See here what value you will get. Okay, here the ff we have assigned as 23.5 and we have casted to the integer, so here you will get only 23. Okay, if I save this and execute the code, see in the output what you are getting. Some of your data will get losted here. Okay, see, you are getting only 23. So whatever all was this 0.5 value, that is just lost it. Okay, so in the explicit casting, some of your data will get lost it. Okay, so this is about the data types and casting in the data type. Okay, so if I go to the slides now, see here type conversion and casting. Okay, so whatever we have seen in the IntelliJ, I just mentioned here. See, for the casting we have two types: implicit or automatic casting and explicit casting. Okay, now implicit casting means what? When one type of data is assigned to another type of variable and the two types are not compatible and the destination type is larger than the source type, then automatic type conversion will take place. Okay, means that whenever let's suppose you have float and double. Okay, now you are trying to assign the double value to the float, right? So they are not compatible with each other, right? That's the reason implicit casting will not happen, and in that case you have to go for explicit type conversion, right? So in the explicit type conversion, what you have to do, you have to cast that explicitly, right? So see here, casting, this explicit type casting is used to explicitly convert the value of one type to another, right? Meaning is that here if you see, we are doing explicit casting, means we are explicitly converting this float data type to the integer. Okay, so whenever you want to convert explicitly a one data type to the another data type, that time you will be using a explicit casting. Okay, now let me just go to the slides. See here, casting precedence of the data type. Okay, so we have these data types, right? So byte is at very lowest, so implicitly you can convert or you can just assign a byte value to the character and short. Okay, and character short values you can assign to the integer, because integer is having a large capacity as compared to the short, character and byte. So all of these values you can assign to the integer. Okay, now long is having a higher capability than integer, and that's the reason the integer value can be easily we can store in the long data type. Okay, and double is having the highest capability or the highest range as compared to the float, so automatically the float data types we can just store in the double. Okay, so this is the casting precedence we have for these data types. Okay, now if I go to the next slide, see, understand it here, the casting concept. Okay, casting is used to explicitly convert the value of one type to another. Okay, now see, here I have mentioned in very easy words, like if you want to cast a smaller data type to a larger one, then implicit casting is done. Okay, now the larger type provides more precision than the smaller type, hence no information is lost when value is casted. Okay, because whenever the implicit casting will happen, here the smaller data type we are assigning to the larger one. Okay, that's the reason the data will not get losted. But when the larger type is assigned to the smaller type, then explicit cast must be required. Okay, and in the explicit casting, the data will get losted. Okay, here see, if you want to understand it in very simple way, for example, let me just open this one, the annotator. Okay, now see here, let's suppose we are understanding the casting. right? Okay, so for the casting we have implicit casting, and we have explicit casting. Okay, now see, implicit means what? If you are trying to assign the smaller data types to larger. Okay, meaning is that, let's suppose you have this box. Okay, this is small box we have, right? And we have something in this small box. Okay, now we have one more box which is larger than this small box. Okay, now if you want to put all of these things, whatever are there in this small box, to this larger box, you can easily put it, right? Because this larger box is having a larger capacity, so all of these things you can just easily put in the larger box, and that's the reason no data will get losted, because here you have a larger space. Okay, so this is implicit casting, means whenever you are trying to convert the smaller data type to the larger one, that time the implicit casting will happen and no data will get losted. Okay, but explicit casting means what? You are trying to convert or cast a larger data type to the smaller one. Okay, meaning is that actually you have this box. Okay, this is a large box you have, right? And this large box is having this much of things. Okay, now what you are trying to do, you are just trying to place all of this larger, whatever values we have in the large box, you are trying to put all of these values into this small box, right? But if you see, this large box is having a big capacity. Okay, but this small box is very small, right? So it doesn't have the capacity to store all of these things, right? So whenever you do the explicit casting, what can be done here? How much this small box can store, all of that things will be stored in this small box, and whatever is remaining will get vanished or will get losted. Okay, so in the implicit casting, no data loss, but in the explicit casting, data loss is there, because you are trying to store the larger value to the smaller data types. Okay, I hope this is clear to everyone by now. Okay, what is the implicit casting and explicit casting? Okay, so what we have learned today, we have learned the what is variable, what are the rules we need to consider while creating the variables. Okay, then the data types like integer, float, short, byte, double, all the data types, primitive data types we have learned, and what size each data type is having, what is the range, and what is the default value. Okay, then type conversion, what is implicit casting and what is explicit casting. Okay, so these are the topics we have covered in today's session. Okay, now I will just stop here for today, and in the next session we will talk about the operators. Okay.